Today I'll be reviewing the practice final exam, problems 16 to 21. So starting with number 16, we are told to solve the problem and refer to the following preference schedule. So we have total number of voters for each column, as well as designated first, second, third, and fourth rankings. So for this problem, you will want to refer to Unit 12B. This has been taken from Unit 12B, and you'll want to refer to page 640. So for Part A, it asks how many voters participated in the survey. So to count the total number of voters, you can add the total number for each column to get the total number of voters. So we have 14 plus 12 plus 10 plus 7 plus 6, which equals 49. So there are 49 total voters. Now for Part B, we are asked to find the plurality winner. So for the plurality winner, you can refer to example number 3 on page 652 to 653, and you can refer to page 643. That may be most helpful. So for plurality, you're going to want to look at the first place votes to see which candidate A, B, C, or D received first place, and if so, how many votes. So we can start with A. So A received 14 first place votes. We see that from column 1. So I'll just go ahead and number the columns. We have columns 1, 2, 3, 4, and 5. So A received 14 first place votes, as you can see from column 1. Now B received 12 first place votes. D, so going from columns 1 to 5, D received 10 first place votes, and C received, so for C we have columns 4 and 5, so it looks like voter groups 7 and 6 voted for C for first place. So we're going to add those voter groups to get 13 votes. So C received 13 first place votes from columns 4 and 5. So with that being said, the plurality winner, according to first place votes, is group A. So the plurality winner is A with 14 votes, which is the majority. Okay, so that's how you would go about 16A and 16B. Now with 16C, we're asked to find the winner by a runoff of the top 2 candidates. So for this problem, we're switching gears a little bit. You'll want to refer to page 643 again, and you can refer to example number 2 on page 652. So for the runoff of the top 2 candidates, we again look at the first place totals like we did for Part B when examining plurality. So again, the first place totals are 14 for A, column 1, 12 for B in column 2, 10 for D in column 3, and again 7 plus 6, so 13 for C from columns 4 and 5. So therefore, the runoff is going to be between the top 2 candidates. So that being said, the top 2 are A with 14 votes and C with 13 first place votes. So the runoff is going to be between candidates A and C. And then we will look at the voters who did not choose A and C, so that being columns 2 and 3. So in columns 2 and 3, 12 voters chose B for first place, and 10 voters chose D for first place. So from here, we'll actually examine who they chose for second place to determine the runoff winner. So that being said, C will pick up these first place votes and wins the runoff over A because both groups voted second place for candidate C. And again, just to clarify, so we said that the runoff is between A and C because they're the top two candidates, with A having 14 votes and C having a total of 13 votes. And so we look at the groups that did not vote for A or C for first place. We have the voters who chose B and D in columns 2 and 3, ranked C second. So C will pick up these first place votes. Oh, that's incorrect. That's supposed to be a C. So C picks up these first place votes of 7 plus 6, and then C will also pick up the votes from columns 2 and 3, so 12 plus 10. So C will win the runoff over A by 35 to 14. So the winner is group C. Next we have problem 16D. So we're told to find the winner of a sequential runoff. So for the sequential runoff, we will actually need to draw new tables. So for 16D, you can refer to pages 643 to 644. And to continue, first, we're going to want to eliminate D, because D had the fewest first place vote at 10 votes in column 3. So by eliminating D, all the votes below D will move up, giving new rankings. Okay, so let's see what that looks like. Okay, so I'm going to draw a new table, but first I'm going to go back to the original table and I am going to highlight or circle all of candidates D so that we can eliminate these from the table. And we are eliminating D again because it has the lowest number of first place votes at 10. Remember, so A has 14 first place votes, B has 12 first place votes, D has 10 first place votes, and C has a total of 13 first place votes. So of the 4 candidates, D has the least first place votes. So we eliminate D and we're going to draw a new table. So our table will have the following. So we have first, second, and third. And now I'll redraw each of the columns. So we have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 columns. And so we're just going to copy each column as is and eliminate D from each column. So we have down the line A, C, and B. We have B, C, and A. We have C, A, and B. C, so all of the votes below D will move up, which give new rankings. And then in column 4, we have C, B, and A. And in column 5, we have C, B, and A again. So now we look at the table, at the new table, and we look to see who has the fewest first place votes again. Oh, and I forgot, you need to carry down the votes. So we have 14 in column 1, 12 in column 2, 10 in column 3, 7 in column 4, and 6 in column 5. So from here, we see that B now has the fewest first place votes at 12. So we're going to eliminate B for the next runoff. So B now has the fewest first place votes and is eliminated for the second runoff. And so now we're going to create a new table. So again, I'm going to circle the B candidates so that we can more easily eliminate the following. We have B, so I'm going to circle all candidates B. And now I'm going to draw a new table. So just to be clear, this is rankings after first runoff, where D is eliminated. So drawing a new table. So we still have the 5 columns. Now we only have 2 rankings, because by eliminating B, we are left with A and C. So we have first place, second place, and we, again, will eliminate B, so rankings below B will move up. Oh yeah, and don't forget to copy the total votes for each column. So that is our new table. Again, these are the rankings after the second runoff, where B is eliminated. And from here, we can see that C is now the leader. And so C is now the leader in first place votes with 12 plus 10 plus 7 plus 6. So a total of 35 votes, followed by A with 14. So therefore, C has a majority of first place votes and is the winner. So that is our final answer for part 16D for the sequential runoff. So that's how you would go about that. So you'd have to create new tables and after each ranking until you get to the top 2. And then from there, you can see who the sequential runoff winner is between the top 2 candidates. Okay, for 16E, we are told to find the winner by a board account. So a board account is a different method. You can refer to page 639 and example number 6 on page 641. So from here, with the board account, you assign points to each ranking. So for instance, the lowest ranking here is 4th place. So any candidates in 4th place will receive a point of, we will use a point of 1. 3rd place will be a point of, will be 2 points. 2nd place will be given 3 points, and 1st place will be given 4 points. So A gets 14 times 4 plus 12 times 1 plus 10 times 2 plus 7 times 2 plus 6 times 1. Okay, so for reference, what I'm doing here is I am assigning points for each ranking for A. So in column 1, I start from column 1, and I see that A has 1st place in column 1 from the 14 voters. So we multiply 14 votes by 4 because we designated 1st place as 4 points. Then we look at column 2, and we see that A received 4th place. So we multiplied 12 votes by 1 because they got 4th place, and 4th place is designated as 1 point. And then we look at column 3, and we see that 10 voters gave A 3rd place, and 3rd place is designated by 2 points, so you multiply 10 by 2 points, 10 votes by 2 points. Then we look at column 4, and we see that 7 voters gave A 3rd place, and 3rd place we have designated as 2 points. And then that's why we multiply 7 by 2. And then we add what we have for column 5. So we see that 6 voters gave A 4th place, which is designated as 1 point, so 6 times 1. And then we add up all of these votes and rankings, and we get a total of 108 votes. So you're going to continue doing that for the rest of the candidates, and then from here you'll see who ranked first by which candidate having the greatest amount of points. So that's the board account. Group C will be ranked first by the board account because it has a total of 160 points, which is the greatest in comparison to the other candidates. And I was saying that the board account falls short because if you compare 16B, the plurality winner is going to be A with 14 first place votes. So as you can see, the board account falls a little short when you consider the majority. So that is something to keep in mind, and we're going to move on to problem 17. So this next problem, 17, asks us to use the approval voting method. So to start, we have, suppose that candidates A and B have moderate political positions, while candidate C is quite liberal. Voter opinions about the candidates are as follows. So we have 27% want A as their first choice, but would also approve of B. 3% want A as their first choice and approve of neither B nor C. 75% want B as their first choice, but would also approve of A. And 45% want C as their first choice and approve of neither A nor B. So if an election is held using the approval voting method, which candidate wins? Well, for this you can refer to page 654. It's actually easiest to list out the candidates so that you can add the votes. So A is approved by, B is approved by, and lastly C is approved by. So once you do that, you're going to want to add up the approval votes. So for A, we can start from the top line and go to the bottom. So A, so 27% want A as their first choice. So we can add 27%. At the same time, we're also told that these 27% would also approve of B. So we can add that to B. Okay, we're done with this line. Okay, so line 2, we have 3% want A as their first choice and approve of neither B nor C. So 3% want A. Now we're done with that second line. Now we're told 75% want B as their first choice. So B as their first choice, so we're going to add that 75% to B, but would also approve of A. So we're going to add 75% to A. So we're done with that third line. Now for line 4, we're told 45% want C as their first choice and approve of neither A nor B. Okay, so we're done with that fourth line. And now we can add the approval votes up to get the sum. So A has 105% approval. B has 102% approval. And C has 45% approval. So therefore, so that's the math symbol for therefore, candidate A wins because they have the highest approval voting at 105%. Okay, so really quick, I already went through and solved the problem since we are running out of time. So for problem 18, you want to refer to the voting power on page 655. You can refer to example number 2 on page 655 to 656. So imagine that a small company has 4 shareholders who hold 28%, 25%, 24%, and 23% of the company's stock. Assume that votes are assigned in proportion to shareholding. Also assume that decisions are made by strict majority vote. Does the individual with 23% hold any effective power in voting? Why or why not? To earn full credit, you must explain your answer. For this type of problem, you're going to want to eliminate the 23% shareholder to see if it can affect the voting. So we're only going to look at the other 3 shareholders at 28%, 25%, and 24% to see what type of majority vote they can form or if they can form a majority vote. So any two of the three largest shareholders can form a majority vote by voting together. As we can see, if the 28% and 25% combine their votes, they'll get a 53% majority. If the 28% and 24% combine, they'll get a 52% majority. However, if the 25% and 24% combine, they'll get a 49% vote, which does not form a majority vote by voting together. And that leaves out 28% and 23%, which will actually form the majority vote in this particular situation. So the shareholder with 23% can be part of a majority with the 28% shareholder to make a 51% majority vote. So therefore, the 23% shareholder has power to affect the election outcome. So the answer in short is yes. So you would need to explain all of this. So you need to have all of this to get full credit for a type of problem like this. For problem 19, we're going to start with 19A. Demographic data for a hypothetical state is given. Use the information to solve the problem. A state has 20 representatives in a population of 16 million. Party affiliations are 70% Republican and 30% Democratic. So if the districts are drawn randomly, what would be the most likely distribution of House seats? For this, we would do the following. We'd calculate a Republican district at random by multiplying the 20 representatives by 70% Republican Party affiliation. And remember, percentages, when multiplying percentages, you want to convert them to decimals. So 70% becomes 0.70 or 0.7. So there will be 14 Republicans. And for Democrats, we'll do the same. We'll multiply the 20 representatives by 30% party affiliation. So again, we convert the percentage to decimal, so 0.3, and we get 6 House seats for Democrats. Therefore, the most likely outcome for the distribution of House seats is 14 Republicans and 6 Democrats. All right, and that would be your final answer for a problem like this. Okay, and so now we're going to move on to 19B. So for 19B, we are told the following. If districts could be drawn without restriction, unlimited gerrymandering, what would be the maximum and minimum number of Republican representatives who could be sent to Congress? Okay, so this problem is quite long, so let me walk you through it. So we first need to calculate how many people will be in each district. And to do so, we are going to need to divide the population of 16 million by the 20 representatives. So we get 800,000. So 800,000 for each district. So now we're going to have multiple parts, but first we need to solve for the number of Republicans it takes to win a district. So we need to find the majority. So in order to do that, we take the 800,000 people in the Republican district and we divide that by 2, and so we'll get 50% of the individuals, but in order to win the district, it needs to have the majority, so we're going to add it by 1. So we get 400,001. So Republicans need 400,001 to win a district. And now we solve for the total number of Republicans in state. So we have, again, 16 million people. We're going to multiply that by the party affiliation of 70%. And again, you'll convert that to a decimal. So we have 16 million multiplied by 0.7, and we get 11,200,000 people. So the total number of Republicans in the state is 11,200,000. So now to solve for the maximum number of districts they could win, Republicans can win, or could win, we take that 11,200,000 and we divide it by the number of Republicans it would take to win a district. So the majority would be 400,001. And we get an approximation. For the quotient, we'll get 27. We want to round down to the nearest whole number, or you give your answer as a maximum number of districts, whichever is smaller. So that's the maximum number of districts that Republicans could win. So we've answered one part, what would be the maximum. Now we need to find the minimum number of Republican representatives who could be sent to Congress. So from here we need to look at the Democrats. So each district is going to have 800,000 people in it. We first solved for that by dividing the population by the number of representatives. So 16 million divided by 20 is 800,000. So each district is going to have 800,000 people in it. So the number of Republicans it takes to win a district is 400,001. So again, we did that by taking the number of people in each district at 800,000 and dividing it in half to get 50% of the population. And to get a majority, we'd have to add by 1, so that's why it's 400,001. The total number of Republicans in the state is 11,200,000, and we solved that by multiplying the population of 16 million by the party affiliation of 70%, so we multiplied by 0.7 to get 11,200,000. And then to solve for the maximum number of districts they could win, we got 27. That was the 11,200,000 total number of Republicans in the state divided by the majority of Republicans needed to win a district at 400,001. We got 27. Remember, you round down to the nearest whole number, or you give your answer as the maximum number of districts, whichever is smaller. And then we went ahead and solved for Democrats. So the total number of Democrats in the state is going to be 4,800,000. We multiplied the population by the party affiliation percentage. And then to find the maximum number of districts Democrats could win, we, like Republicans, took the total number of Democrats in each state and divided it by the majority of Democrats needed to win. So we get approximately 11. We rounded down to 11. And then the minimum number of Republican representatives is going to be the difference of 20 representatives, right? 20 representatives from the original problem, subtracted by the maximum number of districts Democrats could win at 11. So the minimum of 9 Republican representatives are needed to win. And that's how you would go about solving 19b. Okay, so for problem 20, we're told to refer to the figure which shows the distribution of voters in a hypothetical city with 14 Democratic voters and 11 Republican and 5 voters per district. Suppose Republicans are in charge of drawing district boundaries. Is it possible to gerrymander district boundaries so that 2 Republicans and 3 Democrats are elected? You may draw district boundaries in any shape you wish as long as the district is contiguous. Okay, so you can refer to example number 2 on page 679 to 680. There are many, many different answers to this problem. I decided to shape each district boundary in groups of 5. So again, we're looking for 2 Republicans and 3 Democrats. First group is Republican, and then another group that we can draw is that. So the majority here would be Democrats. Another group we can draw here. So this majority would also be Democrat, and another majority would be here. So that's also designated as Democrat. And then here we have majority Republican, so that's Republican. So we have 2 Republicans and 3 Democrats. Again, you can draw district boundaries in any shape you wish. It just needs to meet the following conditions from the problem. This is just how I grouped it, so there is more than one answer. So again, these are the symbols designated for Democratic voter. This is a symbol designated for Republican voter. And as you can see in each group, I have a total of 5. So like this one, majority is Republicans. This group of 5 here, the majority is Democrats. This group here, majority is definitely Democrats. And this group here of 5, all Democrats. And this group here, this group of 5, we have majority of Republicans. So that's why we have 2 Republicans and 3 Democratic district boundaries. So that's problem 20. Okay, so for problem 21, this is a bonus problem. It's an extra credit problem. So the problem states, the rate of new cancer diagnoses among men dropped 3.2% per year between 2009 and 2013. What is the net overall percentage decrease of diagnoses over this 4-year period? Round your answer to the nearest tenth of a percent. So for this problem, you're going to want to use the following formula. Q equals Q naught times 1 minus R to the power of T. Okay, so Q equals Q naught times 1 minus 3.2%. That's our rate, times 4. That's our time, because we have a 4-year period. So from here, we can continue to simplify. So we're going to change that 3.2% to a decimal. So we have 0.032 to the power of 4. Okay, we're going to continue to simplify. So we simplify what's in the parentheses, and we'll get 0.968 to the power of 4. And then we'll simplify that further to 0.878. And then we are going to let Q naught equal 1. And then Q is equal to 0.878. Okay, so if that's the case, we're going to subtract Q naught, our initial value, at 1 by 0.878. And we're going to get 0.1219. We're going to multiply that by 100%. And we're going to round to the nearest tenth of a percent. So we'll get approximately 12.2%. Therefore, the net overall percentage decrease diagnoses over this 4-year period is 12.2%. So it's 12.2% less than the original value. And that is the solution to problem 21. If you have any questions, continue to use the discussion boards and use the messaging system over at Canvas. So good luck on your final exam. And if you have any questions, don't hesitate to ask.